Okay, it's 4 o'clock. Last session of the day. Probably the best session of the day. I'm glad we have people attending today. And the last session of the day is I have to give credit to Jim Montague, Control Magazine. In the June edition, he had a very large, very compelling article around procedural automation and the hows, whats, and whys. And it posed a compelling questions to me that Mike Williams, working with ARC Research, to look into reasons why operators do not follow procedures. There's actually been academic studies done on this, and so I gathered a lot of fundamental research on this, and it's very interesting. And there are some event statistics out there that you're going to see today that prove my premise that the premise of the session is we need higher levels of procedural automation, whether our processes are batch or continuous or hybrid solutions. I will make the case today, and we have two presenters today that Laura Sheets and Tom Kindy, who will show examples of how they've tackled this problem of integrating manual and automated procedures and to drive a performance breakthrough by reducing human variability. Now, we as automation engineers, over the last probably 40 years, our job was, one might say, to eliminate operators. Automate everything we can and take that out of the operator's hand. But essentially, I think we're reaching a point in certain businesses of diminishing returns, the economic return of investing in automation versus human beings, and there's a balance that needs to be achieved when implementing procedural control. So without further ado, again, Mike Williams, ARC Advisory, and here's the proposed case for change. What is this breakthrough? The proposal fundamentally is the integration of automation systems and manual operating discipline, or standard operating procedures, SOPs. The integration of automation and SOPs and fundamentally other management systems could provide a needed breakthrough in process safety, performance, and operational excellence. And what do I mean by the integration of these three separate environments? This slide comes from the Oil and Gas Producers Institute. I stole it from an Exxon presentation at ARC some years ago to give them credit for initially presenting this. But fundamentally, there are three management fundamental systems that have been used over the last 20 years to reduce the rate of abnormal instances. It may be a process safety incident, quality incident, reliability incident, but they all cost us money or cause us regulatory compliance issues. And you see that over the last 20 years, fundamentally, each type of management system and company by company may have changed the order in which they've done these things. There's been improvement over the years. But what I will tell you is the data both from the Chemical and Oil and Gas Institute, from OSHA, from AICHE, fundamentally show that since year 2010, there has been no progress. We've reached an asymptote in our reduction in incident frequency. In fact, though we've reduced the frequency, those remaining incidents that have been occurring are much more serious and much more damaging to human beings, property, and our permits to operate various plants. So there are many sources of this information to validate it, and fundamentally the conclusion from some of the regulatory agencies, and specifically OSHA, is that we need to provide more leading indicators or interventions in order to tackle this issue. And it affects both routine and non-routine operations. So these events are occurring both in the steady state operation as well as unsteady state conditions. The belief fundamentally is the human response to abnormal conditions requires a combination of equipment or process knowledge, you need that in front of the operators, coupled with some assistance to improve human cognitive decision making in conjunction with automated actions. It's an integration problem to break through this asymptote in operational performance. So the data shows there's something there. The premise I'm putting forward is I believe that higher levels of procedural automation can augment the human experience and actually help operators perform more effectively. Real data. Real data that's out there, and it comes from a number of different sources, 3 different sources. The numbers are there. Fundamentally, when you do root cause analysis of abnormal events, whether they be process safety, quality, or productivity events, reliability events, 45% of those instances are allocated to human error, poor execution of human reaction to a abnormal condition. 35% are machine failure, 20% are process problems, chemical process type problems. I took the data and dug a little bit farther though, because the data shows not only primary contributions, but secondary contributions which are contributing to abnormal events. The data shows that additionally, in 25% of the cases, operator error was assigned as a secondary cause of an abnormal event. So simple math, greater than 65 to 70% of the events out there that are happening, unplanned events, have either a primary or secondary cause of the event being operators not executing or responding in a proper manner. So with all the good things that we've been doing over the last 20 years, it's a problem. And we're not making progress. So what can we do? What can we do to augment the human ability to respond in the realm of standard operating procedures which are established and people train on, and in the realm of process automation where we have deterministic execution of tasks in the field? How does that man-machine triangle come together? The focus then, if you say operators have a primary or secondary responsibility, tends to fall back on the operating procedure itself, SOPs. If it's not automated, read the OSHA PSM language. If it's not automated, you must have operating procedures for the effective startup, shutdown, transition, and emergency shutdown of a process, right in the law, in the legislation. So if operating procedures are a fundamental source of the problem of not achieving improvements, what are the reasons? This has been studied by several third parties out there. ARC has a white paper on this. You can look at the statistics for yourself. But there's errors of omission and commission. It comes down to either the work instruction is not sufficient for the task, they run into a situation that's not fully addressed in the documentation, or something had changed in the process and the current procedure is no longer valid. They can't get to the procedure is a book on the shelf, or it's in some file share obscure over here, and I need to go get it, but I can't search for it very effectively. Procedures are long or too hard to read or too hard to interpret. And definitely books on the shelf or electronic file shares are not necessarily integrated with the control system action. And integration to me is not a pointer from a file share and link it to an HMI that says, here it is. Okay, that's not integration by my definition. Certainly it points you in the right direction, but it doesn't it doesn't truly augment or assist the operator in their actions. So how do you avoid the situation of operators not following procedures in a precise and deterministic manner? It requires an integration of some form of the electronic machine, the automation solution, the methods, the intellectual property that's captured around standard operating procedures and automated control strategies, as well as the human being, operator training, behavioral management systems, the carrot and the stick approach, in a integrated fashion. If we can achieve that higher level of integration, it's my proposal that we will be able to better error-proof human cognitive decision-making and provide a new paradigm in the level of procedural automation that will break us through the asymptote that we're seeing in lack of improvement in error prevention. So that's the premise. What are the barriers going forward? You're going to hear two speakers talk about barriers in trying to tackle this particular problem in different ways, but it comes down to finding a balance. I mean, for somebody 40 years in the industry walking around, I mean, we didn't have electronic tools. I had my little black book, a crib sheet that I would take with me when we were going out and executing manual procedures in the field. Everybody had his own crib sheet. They weren't all the same. We essentially did things either by rote. We had the training, but we had our crib sheets. The crib sheets are not necessarily valid procedures. So whether it's electronic paper or physical paper, what are the emerging technologies out there that could help us provide this higher level of integration? I can think of a number of technologies which have been demonstrated in the showcase area this week. So we're going to explore with the presenters some of the barriers to implementing an integrated procedural environment. We're also going to have, with our panel, some discussions then, how does higher levels of automation, how are we supported in doing that with standards such as ISA 88 and 106? And we have a member of that committee here. And I ask you, if at the end of this, whether we're making our case for change, for investments in higher level of procedural automation, and can you see these new technology breakthroughs that could take us to that next level of performance? This is a slide for the end, but ARC is actually investing in a survey that you will get invited to participate in after the forum. And fundamentally, we're looking for input from the user community, systems integrators, as well as OEMs on the levels of procedural automation you have today and what you would expect to achieve that breakthrough in the future. And so we're going to collect more information. We're also going to leverage our existing database around benchmarking. You may be familiar with Dick Hill's benchmarking exercise. We're going to look for trends, look for possibilities that essentially validate our hypothesis that higher levels of procedural automation, much like higher levels of advanced regulatory control, will take us to a new paradigm.